When I mention Zalando, what's the first thing that comes to your mind? Shoes? Fashion? Actually, when I think about Zalando, it's a tech company. And why is that? Because I'm, working, Zalando is one of our clients, but we're working for that company, and I'm amazed by the number of people that are actually working in that company that are tech related. And I think Zalando has done a tremendous job here of becoming a kind of a fashion retailer to a very strong tech company. And that's because if you want to gain critical talent, you're going to need to do something fancy and not just customizing some kind of a Magento shop system or something, right? And that's what Zalando did a great job in focusing on what's the next technological innovation and so forth. And one of those bright minds that work at Zalando and do something around machine learning is today here. So welcome to the stage, Calvin Sewart from the Zalando. That's a applause, right? Thanks for coming. And I switch your presentation.
Yeah, so I guess the step is a great introduction because my talk is going to be about sort of safety first, and I think that the answer to the last question was really great because he said that machine learning is dealing with a lot of the problems that software developers were dealing with in the 90s and 2000s, and somehow one almost feels like the one's reinventing the wheel. And one of these problems is, I don't know if anybody had Windows 2000 or one of these old versions of Windows. You got viruses all the time. Security was terrible. And in machine learning, we're only now waking up to the fact that security is also a problem, and that we need to get serious and get real about securing AI systems. So I'll talk about what this means. So first of all, I'm Calvin Seward. I work at Zalando, and I'm also a doctorate student at the Johannes Kepler University in Linz. My job is cooperation between the two. And so who's heard of Zalando? Okay, a lot of people have heard of Zalando. That's very good. So I don't have to do a long introduction. But who has bought something at Zalando already? Ooh, I need to do some work there. So I can tell you, I bought the pants at Zalando. They're very nice, and it's a great place to work. I can tell you all the things, But lots of places are great to work in Berlin. Zalando is the only place with 40% rebate on clothing. So let me just say that's the reason to work there. It's really great. I can really recommend it. So what am I going to talk about today? First, I'm going to give a bit of a motivation, and the motivation will seem like it has nothing to do with machine learning, but I promise I'll get to the point. Then, after that, I'm going to talk about security challenges in AI, and then I'm going to take a step back, and I'm going to talk a little bit about AI and society, and sort of some thoughts that I've been having there. So over the weekend, I was at a festival. I was at the Baltic Sea festival called Meeresrausch, and it was really fun. It was a really great time. Lots of great music, great people. Whenever you got tired of dancing, you could just jump in the Baltic. I really enjoyed it. The only problem was that they only sold vegetarian food there. So who here is vegetarian? Okay, less people are vegetarian than order at Zalando. I don't know if that's a good or a bad thing, because vegetarianism, I can really support it. You guys, you're great for the environment, great for animals. I tried it, and it just didn't work for me. And the problem is that when I was at the festival, I ate some bread, I ate some cheese, I had an apple, I took a bite out of it, and had a banana, had some pizza, and before you complained about the pizza, it had the salami was tofu salami, yeah. And when I finally got to the carrot, I was like, you know what? I really, really, really want something else. I want some nice bacon, or I'd love to have some chicken, or a nice steak. And then, like it was like some sort of a gift from heaven, lying on the ground, I found something that the gods had given me. There was this really nice sausage just lying on the ground there. So the Germans would call it a Knackwurst. It was like this nice skinny sausage. And I was just like, oh, you've got to be, this is so great. And so like anybody else, I picked it up off the ground, I washed it off, I gave it a quick little sniff, and I ate it. And in retrospect, maybe this wasn't such a great idea, because who's been to one of these festivals, one of these big music festivals? Okay, it's more than the vegetarians, but less than the people who've ordered at Zalando. So in any case, there's a lot of people are walking around, they're sort of barefooted, they're a little bit dirty, and then these barefooted, dirty people probably stepped all over my sausage. And when I think about it, it's probably not such a nice thing. And there's sort of a scientific explanation here. So what we have is we have me here on the right, and we have the apple on the left. And the apple is pretty good, so I ate that. That's fine. I ate the taco. I ate the carrot. Those were all good because they didn't have any bacteria or anything. But then, if I eat the sausage and it's got a bunch of bacteria, I'll get all sick and puke all over the place, and that's no good. And so the same thing actually happens with AI. You wouldn't believe it, but the same thing happens with AI. What can happen is, so this is called food poisoning if I eat something bad and get sick. So the same thing happens with AI, and what happens is if we have an AI and we feed it, some IMNIS digits, or maybe some CFAR, or maybe some nice ImageNet, it'll be quite happy. It'll take the stuff, it'll ingest it, it'll learn it, it'll do some gradient descent, it'll update its weights, and it'll learn to classify the images. But we can also feed it something bad. We can feed it an adversarial image. So this here is an adversarial image. And what happens is when we feed the adversarial image to the AI, we see it gets sick, and it pukes all over the place, and it's really unhappy, and it starts misclassifying all over the place. So this is called data poisoning. It's really called data poisoning, just like food poisoning. And so what's the idea behind data poisoning? So let's think of a simpler example than the image classification. Let's think about the task of spam classification. So the spam filter, we all know what the spam filter is. You get emails from your mom. You want to get those emails. Then you get emails saying, you should take out a huge loan or something like this. You probably don't want these emails, or the Nigerian inheritance scheme emails are very popular. You don't want these emails. And the AI should classify the emails as either ham or spam. Now the question is would it be possible for an attacker to send a bunch of these Nigerian inheritance emails around and like create a bunch of fake accounts, send these Nigerian emails around and classify them as ham, and then classify somehow legitimate looking emails as spam, and shift the AI's behavior this way to where all of a sudden you too start getting Nigerian inheritance emails? And the question is yes, this is actually quite possible. And it works, and it's not so easy in the spam case, but it works very well in the image case. Because in the image case, you're dealing with really high-dimensional spaces, and just one image in this high-dimensional space can quickly shift the boundary, shift the decision boundary to somewhere completely different, to where you start misclassifying a bunch of stuff. So here, what we see is we've got an AI that's been trained on a bunch of images of dogs and other stuff, and we've added one image with a dog and a fish in it. And this image has been changed a little bit to give a little bit of adversarial noise. And by adding this one image with the dog, the fish, and the adversarial noise, the boundary between the dog and the fish has been shifted so far that all of these Pomeranians down here, these cute Pomeranians, get classified as fish. So if you just, yeah, I know, it's really crazy, isn't it? So the algorithm has literally and truly been poisoned with just one bad example. And this is actually a really big problem, because if you have a machine learning algorithm and you're accepting images from users, you don't want your user to be able, your evil user, most of your users are good users, but it's the internet, yeah, so there's a couple of evil people out there. And you don't want that one evil guy to be able to put a bad image in there and completely change your algorithm's classification. And so that's sort of the goal of the talk in a nutshell, is to understand what are the security challenges of AI. And Because at the end of the day, we as technology people, we've got to start to get real about security. Everybody's been saying we got to get real about security for a long time, but really, we do have to get real about security because it's not working. Data is getting lost left and right. There's leaks and there's hacks and everything. And here's just a quick little list, but I'm sure that I know it's not exhaustive. And AI is going to make this even worse because AI represents a new attack surface, a new place that you can attack. So we can think about, let's just do a quick introduction of what an attack vector is. So if you consider an attack vector as a place where you can enter data into, manipulate data in, or extract data from a system. So if you think about the Google search, you can enter data into it by searching. Then you manipulate data in the system because the search is saved, the clicks are saved, and then you extract data from the system. So basically, every sort of customer-facing system, it won't be very interesting if you can't do this stuff. But because you can do this, it allows you to at least have the possibility to do something nefarious. Yeah? Maybe there's somehow a way to do a bunch of queries to where all of a sudden your website pops up in the Google ratings, even though it probably shouldn't have. So that's an attack surface. And AI represents a new attack surface. And it's really hard because what's happening is that we want the AI to perform well even if somebody is inputting adversarial input. Yet, this doesn't fit well with the AI paradigm. The AI paradigm has always been you take your data, you take your label observations, you split it into training data and test data. You train it on the training data, you see if it works well on the test data. If it works well on the test data, you're like, sweetness, this is working really well. And then you use your AI deployment platform of choice and deploy it. But that doesn't tell you whether it's going to work well on adversarial data. Because adversarial data, you don't know beforehand what the adversarial data is going to look like. The adversary decides what the adversarial data is going to look like. And so we need a bit of a paradigm shift in the AI community of thinking about how do we create secure AI that we can deploy and trust that adversaries won't be able to attack it. And the first thing that we have to do in order to create the secure AI is just know what sort of attacks are out there. So I talked about the data poisoning already, but there's two others that I'll quickly mention. One is known as the data extraction or model inversion attack. And there what you're trying to do is you're trying to figure out what was the training data. Oftentimes, models are trained on customer data. For example, like in the last talk, we had the probability of cancellation model. Yeah, that's trained on customer data, and then you can say, here's a nice example. Say you have a customer who's going from point A to point B, and you want to know where that customer is always going. So you always start off at the same place that the customer starts off at, and you see which places get similar predictions to what that customer got. Then you're able to extract data from that. I'll give another example of data extraction in a bit. Then the other thing that we want to know, that we want to be able to prevent, is the so-called adversarial attack. So this is where you put in something that looks like one thing but gets classified as another. And then, of course, we have the model poisoning, or the data poisoning, and we've already talked about this. So the extraction attack. Here's a quick, really simple example. Imagine you have a customer with 9 employees, and now imagine, and they've published the average salary, yeah? Now imagine a 10th customer joins, and they update that average salary. And these numbers are sort of strange, but there's a very specific reason why the numbers are like that. And the reason is because after the 10th employee joins, we can do a little bit of arithmetic and figure out from the 2 averages how much the 10th employee is making. So we've managed to extract personal information about that 10th employee. The 2 averages all by themselves wouldn't have contained personal information, but together they do contain personal information. And AI, when it learns, it does gradient descent and all this other stuff to update weights, And so at the end of the day, it's also doing averaging. So one can ask oneself, is it possible then to come up with a clever attack that's able to extract the training data, just like we were able to extract the salary? And indeed, that is possible. So in 2015, there was a great paper where they showed that if you train a face classifier, you can then figure out which faces were probably in that face classifier. So here on the left, they were able to say that a face that looks sort of like this one was in the training set. And lo and behold, this face on the right was in the training set. And so it's not perfect, but you definitely can recognize the individual. And so just from the model, they were able to extract who was used to train this model and extract sensitive information. So this is definitely something we don't want. The second thing that's interesting is this adversarial attack. So who's seen this before? Oh, a couple of people. So the idea here is that what we can do is if we have something that classifies images, and we just show it a banana, it looks at the banana and it thinks it's a banana. It's quite good. But if we print out this sticker, so this is not computer edited or anything. You just take a sticker, you print it out with a normal printer, you cut it out, you put it next to the banana, and then the classifier thinks that it's a toaster. So very, very different from a banana. And you sort of wonder, well, why does it think it's toaster? But if you sort of squint your eyes and look closely, it actually does sort of look toaster-esque. It's got these nice rounded chrome corners, these nice slots where you put in the bread. And so the AI, it loves this image, and it thinks, wow, that is the most beautiful toaster I've ever seen, and definitely classifies it as a toaster. And so you can do a similar thing where you take an image and you just perturb a couple of pixels, and you get a different classification. So you can imagine that this is a really big problem if in Silicon Valley everybody's driving around their Tesla on autopilot, but you're able to stick stickers on the stop sign, and then the stop sign changes from a stop sign to a go faster sign. Yeah, we don't want that to happen, and so this is definitely a security challenge that we have to address. But let me just say, these adversarial attacks, they're actually not always a bad thing. Think about Facebook. You know, Facebook, they're always trying to figure out everything that they can figure out about you. And if you don't want them to figure everything out, you can put this hat on. And the hat confuses the AI, and they're not able to recognize you. It's called the face-off hat. I hope we'll have it at Zalando soon so that I can buy it with my 40% rebate. And so on this subject that not everything is bad, or not, these attacks aren't always bad, I want to step back and talk a little bit about so one last thought that I've been having. So one last thought, that the adversarial attacks are not always bad. So today is the 17th of June. Who knows why the 17th of June is important in German history? Not so many people. So in any case, it seems like it must be important because there's a street named after it, and the street is actually quite big. So I've noticed that the larger the street, the more important the thing is. So it must be pretty important. And what happened was on the 17th of June, 1953, in East Germany, there were lots of protests. There were lots of protests against the government and the way the government was running things. And the government, they decided that they didn't like it when people protested against the way they run things. And indeed, they disliked it so much that they sent some tanks to stop the protests. And a lot of people died. A lot of people were put into prison. A lot of people were put into prison for a long time. And you had horrific scenes like this, where the tanks were chasing people, the army was firing against people. And the truth is that this happened here. This happened in this place we are now. But we're lucky, and we don't live in a country where political oppression is a fact of life. But in many parts of the world, political oppression still is a fact of daily life. And increasingly, AI is a tool that's used by the oppressors. There's a really great article in the New York Times, it ran a couple months ago, talking about how China uses AI to classify people's faces and discover whether they belong to an ethnic minority. This AI has great consequences because if you seem suspicious, if you seem like you're doing what the government doesn't want you to do, you can, oh yeah, here's a picture of it. You can end up in one of these detention centers. It's estimated that over 1 million Uyghurs, Kazakhs, and other Muslims have been interned without trial in these detention centers. This crime against humanity is horrific, and the fact that the tools that we develop with AI enable this, or help make this process faster and more efficient, horrifies me too. But to know that AI can be attacked, that it has weaknesses, that something that has been programmed to do bad can be tricked into doing good, that gives me hope sometimes. And hope is what we need, because hoping for a better world is the first thing we have to do to have a better world. So, I thank you for coming. I thank you for your time. I thank you.
Thanks so much. Any questions right away? It's hard to come up with a question after this.
Hey, thanks for the talk. I had a question about adversarial examples because I was reading a paper about full bugs, and I was trying to understand about the usage of these adversarial examples. My question is that what is the practical example in Zalando? For example, what is attack, or which kind of things you faced in Zalando or in your data that you ended up with this kind of idea to work your research on it?
So there are examples, but I don't know of any that are publicly available yet. So that have been publicly discussed. So I don't want to give people bad ideas. But it definitely is something that is relevant. Oh, I think one example one can talk about that's fairly well known is fraud. So fraud, it's definitely, you have fraudulent orders and you have not fraudulent orders. So, and there's some orders that seem very, very obviously fraudulent. And fraudsters are always trying to figure out how they can come up with orders that seem just unfraudulent enough to where they can order and get the items and defraud either Zalando or defraud whoever's credit card number they're using. So I think that's an example that I can talk about.
You can also do it with voice. So adversarial attack against the voice, and after your Alexa ordering something for you, unfortunately. I have a question. You mentioned the model extraction. Do you do anything in Zalando with differential privacy? Like that you actually differential privacy? So you're trying to a bit noise the data so you cannot extract and you cannot, rely on single people?
So with the extraction, one interesting place where you can try and extract data is the search. So you have this little search query, and there's always a bit of an autocomplete that happens. And if this autocomplete is configured badly, then it could be that maybe somebody has searched for something that's a little bit embarrassing. Like, hi, my name is Calvin Seward, and I really like to wear black leather underwear around at work, or something like this. And somebody's entered this really long and really sort of personal query into the query. And then the AI has learned if the sentence starts with, "Hi, my name is Calvin Seward," then it should end with, "I really like to wear black leather underwear at work." Okay? And so if the AI learns this, and then the attacker is you guys can try this out at home if you want. You can try and attack Zalando and see if it works. Enters in, "Hi, my name is Calvin Seward," and the autocomplete completes it with, "And I like to wear black underwear at work," then this is pretty bad. This is leaking the data. And so there's actually a strategy against this where you split the data up into different different bins and make sure that each bin doesn't contain that no bin contains the same customer twice. Then you train separate models on the data from each one of these bins, and then if all the models agree, then it's sort of a trend, So like, it's hot and I'm looking for a summer, everybody would know dress is the next word because that's a trend. But the "Hi, I'm Calvin Seward," that's not a trend. Nobody else would search for that. I'm the only one who would search for that. And so all the models would disagree on this one. And only if they agree will you give a suggestion. And that way, my personal information can stay safe. Yeah? Yeah, so the question was, so I've talked about how to attack, but not how to protect. It's a good question. So I won't talk too much about it since I want to be invited back sometime, and then I'll have something to talk about next time. But let me just say that the adversarial attack is an open question. The data extraction can be solved with this binning technique that I talked about, and then the model poisoning is also an open question. And then there's one other attack that's very popular called model duplication, I think, where you try and learn a model, and there you can use sort of differential privacy techniques to do that. So yeah, that's the short answer. But in another talk, I can go into strategies that seem to be promising.
One last question? No. Thanks so much, Calvin.
All right, thank you.
Really, really good.